Saxon Algebra 1, Lesson 35. We have multiple parts to this lesson, so technically I should have written this down here. If I write it up here, that usually means it's just one topic for the lesson. If I write it here, that means it's the first topic of multiple parts. But I forgot, so sorry. Okay, we're going to talk about the greatest common factor again. That's what we talked about in the last lesson, and I explained to you that when we take an expression like this and we distribute, right? We multiply across and we get something like this. That's called distributing, and we're pros at that. But sometimes we have an expression like this and we want to change it back into that form. Remember, there's no better or worse between these two forms. It's just a question of what else you might need to do with it. This process is called factoring. And the whatever it is that we can pull out of both of the other terms, we call that the greatest common factor. And in our last lesson, we practiced identifying what the A would be. This time, we're going to kind of complete the whole thing. Not only are we going to identify the A, but we'll figure out how to calculate the B and the C parts as well. So we're just refining our ability to do this. So let's dive in, shall we? Here's our expression. Okay, so our first thing that we need to do is we need to find the A. We need to find the pieces that both of these terms have in common. And we can see, oh look, they both have a 2, and they both have an A, don't they? There's the 2's, there's the A's. So we pull those two out, just like we pull the A out here. And then what's left over of each term will become the B and the C. So in this case, we have an X, and in this case, we have a C. We just copy that same sign, X plus C. This is our answer. And as you can see, this number is the greatest common factor. Well, it's a number with a letter, but you know what I mean. That's equal to the A, right? We pulled it out of both of these. And this one's literally a C, but these are like these pieces where they're what's left over after we take out the A, all right? So I'm kind of matching my answer here to the way we've written it up here. So that's going to be the process for all of these. We're going to do it a lot. There are quite a few of these examples, and this is something that we do in math all the time. All right, it gets a little crazy when we have lots of letters and exponents and such, like this problem. These are problems where it is super helpful to write each term with its letters in alphabetical order. We're going to be comparing back and forth between them. You'll notice this one has 3 different terms. If we put them in alphabetical order, it makes our job much easier and it makes it much simpler to get the problem right without mistakes, which is always my goal. Another thing that I always like to do is fill in any missing exponents with a 1, right? We remember that anything without an exponent can be written to the power of 1, and that's helpful. Okay, we'll also remember our shortcut that in building the greatest common factor, we can compare the letter and take the lowest exponent out, right? Whichever term has the lowest exponent, that's what we can pull out. So here we have an A cubed, an A squared, and A fourth to the 4th. The squared is the lowest, so that is going to be part of our greatest common factor. Now we move on to the m's. M squared, M to the 3rd, M squared. Okay, M squared is the smallest that they all have. And then X. X squared, X to the 1, X to the 3rd. So we just pull an X, and we can write the 1 there if we want. Okay, it's up to us. We can do it or not. So here's my greatest common factor. Now in the parentheses, I'm going to write the leftovers. What's left of each term after I pull this out? Okay, in this first term, there will be one A left, no M's, I took all the M's, and there will be one more X. Copy the sign. Now I'm comparing the greatest common factor to the second term. We took all the A's, there's one M left, took the X, that's fine. Copy that. A squared. We took all the M's, and there are two X's left. This is our final answer. Okay, so that's not just, there's the greatest common factor, and then there are the pieces that are left over after we pulled that greatest common factor out, just like this. There are three pieces, that doesn't change anything. It's still the same. I got both of these right. Okay, there are 5 of these in all? Yes, and then we have a second topic that's fun. It's algebra. $35.3. Okay, I'll let you finish copying that. Again, I will say that what I like to do, I'm just double checking to make sure I got this right. If I have a variable without an exponent, I just put that 1 on him to make sure that I can compare them easily. We make sure that they're in alphabetical order. If John puts them out of order, fix them as you copy them onto your paper. It helps so much when you're comparing if you can just go in alphabetical order. Okay, let's do the numbers first. The numbers are honestly sometimes the hardest part because the letters are so easy. 4 and 2. If you need to, you can always break numbers down into their primes, and that helps you compare really easily. These two have a 2 in common. We take the lower exponent, a squared, plain b, I'll put b to the 1, and z to the 3rd. They have to both have the exponent, they have to have the same letter. Like if this one didn't have a z, I couldn't say, oh, z to the 4th is the lowest, I'll take it. Because they both don't have a z, right? They have to have the same variable. Then once you determine that they do, then you pull the lowest of the two variables. But they have to both have the same one. Okay, so this is my greatest common factor, and now I look and see what's left. I can see here by my prime factoring that when I pulled out one of the 2's, the other 2 was left behind. So I needed 2. And then I pulled out a squared, and there's a cubed, so I need one more a. B, I'm gonna need 3 more of those. And then the z's are completely done. Plus, this sign is always the same. It doesn't matter if it's positive or negative, it doesn't really change. Here we pulled the whole 2 out, the a's match, the b's match, and just all we have is a z. Z to the 1 if you like. I'm gonna leave it just plain. I'll put a 1 on it. This is our final answer. Remember that you can always check your answer if you want to. Multiplying this times this should give you that. Multiplying this times this should give you that. So you can always check if you're feeling unsure. Okay, here's our next problem, our next challenge. Factor the greatest common factor of blah, blah, blah. That's straightforward. So again, if we want to, these numbers are low enough that you can kind of do the numbers almost by guessing, but we'll just write out the prime factors because that'll make it easy for us to do our calculations. We can see that when we break the numbers down into the prime factors, the only factor that they all share is a single 2. So I'll put that here. That's part of our greatest common factor. Now I'm going to compare the letters. A squared, a cubed, a fourth. Okay, they all have an A, so I can pull the lowest one, a squared. X squared, x cubed, they all have an X, so I can pull the lowest one, x squared. This is my greatest common factor. Now I'll go back and gather up the missing pieces and put that into the parentheses. All right, when I pulled the 2 out of this 6, I was left with a 3. But look, we got all the A's and we got all the X's. So that's all for the first term. Plus, okay, when I pulled the 2, I took the whole number, so there's nothing left. Let's see, a squared, and this is a cubed, so there's one more A. And same with the X's, there's one more X. Plus, okay, we pulled one of the 2's, it's here. That means we have another 2. We have 2 more A's and 1 more X. And this is our final answer. Again, remember, if you're unsure or for any reason you want to check your work, you can multiply back, right? This whole thing times 3 would give us 6 a squared x squared. This times this would give us 2a cubed x cubed. And this times this would give us 4a to the 4th x to the 3rd. Yay, it works. Okay, one more. One thing I like about these problems is that they don't take a lot of writing, right? All right. Here are our expressions. What can we pull? Okay, here's a number, but there's no number here, so we can't pull the 3. We can take, there's an m cubed and an m squared, so they both have m's. We can take the lower exponent, that's a 2. X, this has an x, but this does not have an x. Here, let's put 1s on these just for fun. This has an x, this is no x, so we can't pull the x. This has a y. They both have a y to the 1, so I can pull out the single y. I choose not to write the 1 there. Again, I can take that 1 off or put it on any old time I want. So this is our greatest common factor. Now we have to see what's left behind. Well, we couldn't take the 3. There's one more m. And there's an x. Oh, this I think is a squared. Let me double check. Yeah, this should be a squared. So that doesn't change our greatest common factor, but it does mean there's a y here. Now, we look at the last term and go, wait a minute. M squared, we took out the m squared. Y, we took out the y. What's left? Some students want to just close that off and say that's the end, but that's not the right answer. And I can prove it to you because if we just leave it like this and then we distribute to try to get our original expression back, we're not going to get it, right? We're only going to get this term back. So we have to have something down here to represent this last term. And let me remind you that if we have m squared y and we pull out an m squared y, that's like dividing it, that equals 1. So the placeholder we need down here is just a plus 1. This is a tricky part of factoring that students often get wrong. And remember, you can double check your thinking by saying, okay, if I multiply this by this, I get this back, right? 3m to the 3rd x y squared. And then if I multiply this times this, I get this m squared y. Yay, that's what I want. So this is the right answer. Remember that if you pull all the pieces of one of your terms to represent the greatest common factor, you're left with a 1, not a 0, right? And there's proof of it. All right, That's the right answer. Okay, this is the right answer too. Let me just double check. I'd hate to be wrong. BZ to the third. Yes, that's correct. You can put the ones on or leave them off. Again, it's totally fine either way. The convention is to present things as simply as possible. So normally we take them off, but it's not wrong to put them on. If you gave me an answer to a test question with ones like that or a review problem, I wouldn't bat an eyelash. You'd get full marks. Okay, so that is factoring out what we call the greatest common factor. Our next topic is canceling, and they're related. All right, now we know that if we have something like this, right? We can cancel those two and it will just be x. But here's a weird thing. If we have this, notice here I'm multiplying, here I'm adding, we cannot cancel this plus sign prevents us from canceling. And when I say adding, it could be a minus sign as well, plus or minus, right? We can only cancel when multiplying. And we'll do a couple problems to show you what we mean by this. They're straightforward. Here, we were multiplying the 4 times the x, so we were multiplying and we're allowed to cancel. Here we are adding. We cannot cancel when adding, so we cannot cancel those 4s. All right, let's just look at a handful of examples here to help you understand that. A. All right, so students look at this and go, oh, but look, we're subtracting, so we can't cancel. We're subtracting within the parentheses, but this 4 is being multiplied by this a minus 3 quantity. So this is multiplying, and we are allowed to cancel. So our final answer here would be a minus 3. Okay, this is the part that's being multiplied, so it's okay to do that. B. Here, we're multiplying the 3 times the x minus 2, but we want to cancel not the 3, we want to cancel the x minus 2. Are we allowed to cancel this? Because we're subtracting. Isn't this a no-fly zone? But here's the thing. We're not subtracting part of the quantity. We're not canceling part of the quantity. We want to cancel the whole quantity. We are allowed to do this. And the important thing is right here. We're not adding or subtracting here. We're multiplying here. So this would reduce to just plain 3. That seems weird, doesn't it? We can be subtracting as long as we're canceling the entire quantity. We couldn't cancel, say, the 2's or the x's, but we can cancel the whole quantity. Okay, canceling in general is highly desirable. We want to cancel whenever we can because it makes things simple. Okay, so there was a little 2-part example. Now we have 1, 2, 3 more canceling examples. This is a long lesson. But these are important rules. And This we'll see. We're gonna do this a lot in our future math lives too. Okay, here we see, all right, we can't cancel these 3's because we're adding here, right? This screws everything up. We can't cancel this way because this term is being added to the 3. But here's what we can do. We can factor first. Excuse me. I might sneeze again. I often sneeze in pairs. When I was growing up, our next door neighbor, a man named Jerry DeWolf, he used to sneeze. Every time he would sneeze 7 times in a row, fast. Always 7 times. And I remember my mom telling me that when I was fairly little, I don't know, 6 or 7. And I remember being outside playing in my yard and I'd hear him start to sneeze and I would always count. And sometimes he would do like 6 in a row really fast or like 5 really fast and then 1 and I'd be hanging on like, where's that last sneeze? And he would always sneeze. It was so funny. Okay, so what we're gonna do here is we're gonna factor out the 3 in the numerator, right? We can change that and it would be 3 is the greatest common factor and then we would have P, and then as we just learned, we'd need a placeholder of a 1 there, right? And that way when we distribute, we get that back, okay? Now we can cancel because this 3 is now being multiplied by this quantity. So our final answer would be P plus 1. Crazy, right? So if you can factor first, then we can very often get it to work out and we can eventually cancel, but we can't cancel at this point until you're fast enough that you learn how to do it in your head. Point 8, it is 3x minus 9x squared. Okay, and so we train our eye. And John sets these up so that it works out perfectly, but we can see, oh look, it would be nice to cancel, and we can see that there is a 3x inside of this term, but we can't cancel at this point. We need to factor first. So we will factor the top, and let's see, we can take a 3x out of both sides. We just have to pray that John is nice to us. That'll give us a 1 minus, and then there's another 3x. Then we're dividing it by our 3x. Now these guys cancel, and our final answer is 1 minus 3x. Notice that there's no way to cancel this against this, because again, this is being added. We can't break this up, but we can cancel against this. This is our final answer. Yay! And one more. This one is 5x minus okay, a lot of times with these problems, we can't necessarily see how it's going to end up, but we just go, okay, well, let's try factoring the top and see what happens, right? So I'm going to go over here. I'm going to pull out a 5x because I can see there's a 5x in both of these. And it will be 1 minus the other 5x, right? Because 5 times 5 is 25. X times x is x squared. And we're dividing it by 5xy. Now notice the bottom is all being multiplied. So I can cancel any part of that I want. I can cancel the 5's. And I can cancel the x's. And so my final answer will be 1 minus 5x over y. Fun, right? Straightforward, nice, crisp, clean algebra. I hope that was a lesson that feels neat and tidy in your head and your Jenga tower is strong and firm. Okay, that's all for lesson 35. Thank you, goodbye.